Hey fellow coders, welcome to GameDev with Tony. Scriptable objects are a powerful feature in Unity to efficiently store and manage your game's content outside of scenes. In this video, we'll learn how to implement two practical styles of scriptable objects to construct a digital storybook, with scriptable objects serving as the containers for all the necessary page data. We'll cover both an array-based structure and a node-based linked list system, showing how each approach allows you to navigate through its pages. Let's dive in. Before we start on the project, let's get a better idea of what scriptable objects are and how we can use them. In simple terms, think of a scriptable object as a data container that exists independently of any game object or scene. You would define its structure and it can store information you need for your game. So what kind of information, you may be wondering? One example could be the configuration settings of a game, such as the screen width and height, a full screen flag, and maybe the volume level. Another could be a list of high scores, along with the names or initials of the players. Character dialogue is a good use case, and that's actually something we'll explore in a later video. For this tutorial, scriptable objects will be used to represent the page data of our storybook, the images and the text to be shown as we move through the pages. Scriptable objects live in your Unity project as assets, but you can write code to serialize their data to and from files like XML, JSON, or even a database as an example. With those details in mind, let's go to the project. As always, we start with a blank slate and take it step by step. All the assets are up on GitHub and the link is in the description. There's going to be some project prep first before we get to the scriptable objects, so if you're here for the quick how-to, feel free to jump ahead. There's a timestamp in the description. We need to bring in the assets. Start by creating 4 folders. Name them Scripts, Sprites, Scriptables 1, and Scriptables 2. Then head into Sprites. There are 2 sets of images we'll import. One is for testing and the other is for the storybook. Drag those folders in. Update the image properties to use point no filter and no compression. The next step is to build the interface. In the hierarchy, add a game object and call it Storybook. Create a child on it and name that Image 1. It will only have one component, a sprite renderer. Select Image 1 and hit Ctrl-D on the keyboard to duplicate it. Rename it to Image 2. These 2 image objects will act as flipping between the pages. Assign the stripe sprite to the image 1 and the dots to image 2. If your dots happen to appear above the stripes, you can change the sorting order on the sprite renderer. Set image 1 to 2 and image 2 to 1. We'll add the UI controls next. Start with a text object and call it StoryText. Adjust its properties. You can leave the default text if you want, since it'll be changed when the app runs. Set the font size to 40, vertically align the text to the middle, and color it solid white. We'll anchor it to the bottom middle. Hold down the Alt key when you click the button, and Shift when you click it a second time. Update the width and height to 600 and 160. Create a child on the canvas and call it Scriptables 1. This will be a group for our paging buttons. Anchor it to the bottom middle the same way you did for the text object. Add a child button to it and call it Previous Button. Set its text to say Previous and size it to 28. Adjust the button width and height to 200 by 80, and set its X and Y position to -500 and 40. Duplicate the button and call it Next Button. Change the text to say Next and set the X position to +500. Duplicate the Scriptables 1 object and call it Scriptables 2. Each group of controls will have a different script listen for button clicks. On the canvas, change the UI scale mode to scale with screen size. Set the resolution to 1920 by 1080. For now, we won't need the canvas, so we'll disable it. That does it for making the Storybook UI. To enhance the transition between the page images, we'll script a fade effect. I'm not going to spend too much time explaining this part since it's eye candy, but I put plenty of comments in the code. In the scripts folder, create a C# file called Fade Transition and open it in Visual Studio. Several variables are declared. The first 2 will have the sprite renderers from the image objects assigned to them through the inspector. The second 2 act as a swapping mechanism for the layers. A bool to track if we call the setImage method its first time. Another one to allow the fade code to execute. Timer variables for calculating the fade progress. And the last one is an action delegate. Its purpose is to act as a callback. For this script, the callback is assigned by a different script calling it, and it runs at the end of the fade, signaling the fade is finished. Now it can do something else if it needs to. You'll see what I mean later. In the start, the image sprite renderers are assigned to the layer renderers, also the sorting orders, and colors of transparency and normal. Jumping to the update method. The way it works is the image object that is considered topmost starts out transparent, containing the next image to be shown. You'll see the image of the lower layer, the one you're transitioning away from first. When the fade happens, the opacity will increase over delta time to the delay amount, slowly revealing the new image above the lower one. Once the threshold is hit, the layers and orders are swapped, ready to do it all over again. Included is a key press for the spacebar to test out the fade. Values are calculated and clamped, and once the fade finishes, if an action is set, it gets executed. Then we end with two public functions, setImage and fade. SetImage applies the sprite to the corresponding image object. On the first run, we make sure it's set to image 1. After that, it depends on the sorting order. The fade is called from wherever you want to initiate it. In this project, the Storybook will be doing it. Now that we have the fade script, we'll attach it to the Storybook object and assign image 1 and image 2 to reference their sprite renderers. You can see when pressing the spacebar, we fade between the two images. The speed of the delay can be adjusted in the inspector. You could add a public function to control it through scripting if you wanted, but for this demo, a 1-second delay is good for the Storybook. Now that all the prep is done, we can get to the core of the video, scriptable objects. We'll tackle the first approach, array-based pages. In the scripts folder, create a new C# file and name it Scriptable Story 1. As I mentioned earlier, a scriptable object at its basic level is a data container. What kind of information or functionality it has depends on how you code it. This first approach will store our pages as an array list. The page is defined by a structure called storyPage, and the scriptable object will contain an array of pages. The structure is simple. There is a string for the descriptive name of the page. This is internal to us to know what the page is about. Next is a sprite that will be shown when the page is active. And finally, the text of the page that tells the part of the story. After the structure, we use createAssetMenu to instruct Unity to give us a menu so that we can create our scriptable object in the editor. Then we have the actual class for our scriptable object. You'll see it inherits from scriptable object. Whenever you create a new C# script, it defaults to mono behavior. So make sure if you're typing this in, the class to the right of the colon is scriptable object. In the class, we set up an array list and declare a private integer that will track which page index we're on. After that, we have 4 public functions. GetPage returns the current page object we're on so that we can read the sprite and text. Then getPageIndex returns the value of the current array index. And previous page and next page allow us to move between pages, with safeguards to not overstep our bounds. Now that we have defined what our scriptable object looks like, Unity will let us create it. Right-click and you'll see at the top of the menu the submenus we defined with createAssetMenu. Name the scriptable object Horror Story 1. There's the pages array, but it doesn't have any elements yet. Add 4 by clicking the plus button. You can see that each element contains the fields that were described in the story page structure. I'm going to fill this out and I'll be right back. The story is short. It starts at a door, then it moves to a hallway, and then walking in the hallway and finally facing a monster. The page images and texts are assigned. You can reorder the pages by dragging the elements around, plus add and remove pages. It's flexible just like any other array. Okay, great. We have a scriptable object containing our story. The next task is to show and control it. Create a C# file called Storybook1. The first 2 serialized fields are to the scriptable object story and the UI text object. Then a bool to allow the paging buttons to work. A reference to the fade script attached to the Storybook object. And a delegate action that we want the fade script to call when the fade completes. In the start, we get the fade script and assign our callback method to the delegate. The commented lines are to test out our callback, but we'll use those after we get through the rest of the script. Finally, we use the methods from our scriptable object to get the page and assign the story text to the UI and the sprite to the fade script. The update contains code to test the fade and the callback by left mouse click. The public click handler function is where the magic happens. I've placed a lot of comments and debug lines so you can see as things happen in the console. Allow paging is checked and the function is exited if we don't want the buttons to respond, such as if we're in the middle of a fade. The string parameter method is tested against the value previous. If it's true, we previous page or move left in the story. Otherwise, we next page or move right in the story. Then the page text and image are assigned. We call the fade function, supplying it our callback. Last, we set allow paging to false so button clicks won't respond, since we just started the fade. The callback function we supply is called fade completed, and the only thing it does is reset the allow paging flag back to true. The last two functions are for testing the action delegate. Back up in the start and update, change the comments to what you see on screen. We're going to test out the fade callback before we try the storybook. To add a function to a delegate, you code it like an addition. A delegate can take many functions and they'll execute in sequence. Here we pass it do something 1 and do something 2. In the update, after the fade is called, we set the delegate to null, effectively removing any attached functions. If you were to leave that commented out, the functions would stay on the delegate. I included it so you can see how to remove them. Add the Storybook 1 script onto the Storybook object. We need to assign it the horror story scriptable object and the UI text. Left-click and after the fade finishes, you should see the two callbacks run their code in the console. Upon another click, the callbacks don't run because we set the delegate to null. You can change the comments back to how they were in the script. Now we can reactivate the canvas, but disable the Scriptable's to child. For the array-based approach, our click handler will be assigned to the first group of buttons. Select the previous button and in the properties, scroll down to onClick. Hit the plus button to add an empty event. Click the little knob and then select the scene option. Select the Storybook object. Of the available classes, select Storybook 1 and then choose the click handler. In the field below, type previous. This is the string parameter passed to the handler. Repeat the same process for the next button, but use next for the string parameter. Our Storybook has loaded the first page. The image is shown and the text is in the UI. Clicking next, it advances to the next page, applying our fade transition, and the callback is being executed. Repeatedly clicking the next or previous buttons during the fade do nothing, because the allow paging flag is false, until the callback reverts it back to true. That was a taste of scriptable objects, but we're not done. The next phase is to use a node-based linked list approach. Each page will be a scriptable object, and the pages will be linked to each other through references, and a manager class will be created to control the movement between the pages. Create 3 new C# scripts. Name them Scriptable Story 2, Story Manager, and Storybook 2. Starting with the Scriptable Story 2. It's very similar to the first one, but each page is an object. The notable difference is the previous page and next page variables. They are of the same type as the scriptable object. This is how we create the linked list. Next is the Story Manager. The page functionality that was in the array-based scriptable object has been separated out into a manager class. The initial page is assigned to the start page variable through the inspector. Then we have a private variable for the current page. There is no indexing this time. GetPage operates similar as in the first approach by returning a copy of the current page. The previous and next page functions test for a valid current page and whether a link in the chain exists. If successful, the next page or previous page is loaded accordingly. Finally, the Storybook 2 class is almost a carbon copy of the first version. However, it requires the Story Manager to be present and attempts to reference it in the awake function. The start initialization, click handler, and fade functions are the same. However, the way we get the page is subtly different because now it's coming from the Story Manager, along with the paging functionality. Head over to the Scriptables 2 folder. Right-click and you'll see our new scriptable object in the menu. We'll create 4 of them, 1 for each page. I'm going to prefix the names with numbers so they visually stay in order. So 01 door, 02 hallway, 03 walking, and 04 monster. You can see they have the same inputs for the story data, except now we have 2 fields to link the previous and next pages. I'm going to fill these out and I'll be right back. As you can see, the data is the same. I left the linking part out so you can see how it's done. Starting with the door, since it's the first page, nothing would be assigned to the previous page. But for the next page, add the hallway. In the hallway, the previous page will be the door, and the next page is walking. For walking, the previous page is the hallway, and the next page is the monster. On the monster page, since it's last, the next page wouldn't be assigned anything, but previous page is walking. On the Storybook 2 object, attach the Story Manager and Storybook 2 scripts. For the Manager, assign it the door page, and in the Storybook 2, assign the UI text object. Last, uncheck the Storybook 1 script. Back in the canvas, disable the Scriptables 1 group and activate Scriptables 2. Just like before, add the click event for the previous button, but this time make sure to choose the Storybook 2 class and its click handler. Add the string previous for the parameter. Do the same for the next button, but put next for the parameter. Here comes the fun part. Let's give it a go. Everything should look the same as before. The page sprite and text are visible. Clicking the next button loads the next page. The fade is working, and you can see there aren't a bunch of debug statements like before. We can move through the story in both directions and don't overstep any bounds. And that brings us to the end of the video. I hope you learned something new and you'll now be able to harness the power of scriptable objects in your games. If you enjoyed the video, consider giving it a like and subscribing to the channel. This is GameDev with Tony signing off. I'll see you in the next video. Take care.